Welcome to 3 Devs and a Maybe, the podcast series for beginner web developers and general web enthusiasts. Now, introducing your show hosts, Michael Budd, Fraser Hart, Lewis Keynes, and Ed Mann.
Hello and welcome to another episode of 3 Devs and a Maybe. My name's Ed Mann, and today we are very lucky to be joined by Mattias Geniar. How you doing, Mattias?
I'm fine, Ed. How are you?
I'm very good, thank you. Just before what we're doing off air, so speaking of off air, was the sound of your microphone. It's great, and it's all my fault for you to be getting a Yeti, so I will take that blame.
Does that also mean that I can send you the invoice, or is that still on me?
That's the 3 Devs and a Maybe. We're giving out microphones.
Now, I've been thinking of buying a Yeti a long time. It was on sale about 3 or 4 weeks ago, I think, on Amazon, and I thought, hey, why not? This is the perfect time to get one.
Absolutely. Yeah. And you're enjoying it. Have you been able to use it much in your day job and things like that at the moment, or is it really just for like podcasting and things?
I've just gotten it out of the box, so this is the first time I'm using it.
Oh, wow. Brilliant.
We'll see how this goes.
Fresh new Yeti. Very nice. So for the audience, so essentially another thing that kind of has been, well, I mean, everyone should know, actually. This is the web development podcast, and obviously HTTP 2 has it been finalized? It's been released. It's been kind of around for a while now, but is it officially the spec being released?
There have been a number of, predecessors to HTTP 2. We've had the Speedy protocol for a very long time that Google initiated. The final draft, the final version of HTTP 2, is effectively out. It's been out for a couple of months now, if almost a year, I think. So yes, it's final. HTTP 2 is here, and it's here to stay.
Well, hey, and really, it's kind of a great time to kind of look into this now by being web developers. And one of the things, obviously, typical running theme through these podcasts is I go on the Google, search for, good resources, and your name comes up all the time for this stuff. And I really enjoy your blog. So I thought, let's give it a shot, try and get you on. You were really nice to come on the show. And let's geek out and talk about HTTP 2, I thought, which would be a really cool topic.
Oh yeah, it's definitely one of my favorite topics. I've been blogging and giving presentations about it for quite some time. I'm glad to hear that you're finding my blog and that you're even finding it useful.
Oh, absolutely. It's a great blog. I mean, you talk at so many different things like Varnish and general PHP things and the Unix sysadmin stuff. And I suppose actually, talking about like that kind of DevOps, like how did you get into programming and DevOps? Like how did you get into the position you're currently at?
Well, it's started as me being 13, 14 years, I don't know, playing around with PHP, which is now about 15 years ago, so I'm talking about an ancient PHP version. But when I was 14, I thought, hey, what if I start to get into programming? Maybe I could start a website at my school, and maybe I could start the kind of website that allows us to exchange homeworks. So only one person has to make it, he can upload it, and all the entire school can get use of it. So yeah, me being a lazy programmer, I spent a lot of time programming, not that lazy. But I got into PHP that way. There was a very fun way to get hooked into it. I taught it to myself. But this was PHP 4, I think, so nothing object-oriented, just plain procedural, one line after the other. Still readable, actually, so yeah, big up for plain old PHP. But that's how I got started. Then I went into just studying programming, system administration, etc. Then I got into, work. Started as a PHP developer at Nucleus. There's a hosting provider in Belgium. We do cloud hosting and everything else. Started as a PHP guy. Slowly started to manage my own servers. Now I'm just the server guy, no longer the PHP guy.
Did you miss the PHP role? Do you love the DevOps side?
I still love it. I still, officially I'm not a PHP developer, but I still write PHP, either in side projects or just to automate something simple at a command line, which Bash is limited at. PHP is my go-to language to get anything done.
Yeah, because I do actually feel like PHP is underrated in that kind of thing. Just the command line scripts you can make with it and quickly whip up things, as you say, that be a bit more advanced than what Bash does. I mean, again, people will show you Bash commands and awk commands and all these things that will do the same thing, but for readability, I go to PHP as like my tool for like these little scripts.
Same, and I think it's just personal preference. If I were to get started in, say, Python, no doubt my go-to language would have been Python. So it's a means to an end. You automate something to get something done. It doesn't really matter which language you use.
That's it. Absolutely. It does its job. And so how long have you been doing the DevOps stuff then, as opposed to primarily the PHP programming side?
It sort of depends what you think of as DevOps. It's a wide term and everybody's using it in its own interpretation. If I'm looking at DevOps as something like the typical definition of infrastructure as code, I think it's about 4 or 5 years now. But DevOps is more than just writing your server infrastructure in code. It's also automation. It's just getting things done in a way that's maintainable, that you can...
The architecture around it, everything.
So much more, indeed.
Stuff. Yeah. Absolutely. And I suppose, what kind of stack then do you run currently at your work? Are you able to talk about that a little bit?
At our work, we do everything in Puppet. Puppet's our config management choice, which we made about 4 years ago, I think. Back then, there weren't that many alternatives. I think if we were to reevaluate today, I'm pretty sure Puppet would still be in the top, but it may not be the answer today. I think with Chef and Ansible seriously catching up, it could have been a different definition at the end. But hey, we're running Puppet. We're doing it all the time. All our servers are from beginning to end automated with Puppet. So I spend most of my days at a command line, in a text editor, writing Puppet modules, manifests, everything like that. And where possible, writing scripts in either PHP or Bash or anything just to automate everything.
That's awesome. And how do you find Puppet? Like, as you say, like there's the other ones, Chef and Ansible, and Puppet was kind of one of the first. It was there. Chef and Ansible, Chef and Puppet seem to be the first kind of foray into it, and then Ansible's come on the scene. So what do you prefer? Did you like the way how declarative Puppet is and the way that it kind of its thought pattern?
Well, I'm glad that Puppet wasn't the first one. It's had its older brother with CF Engine, which I think originally came from Facebook. It's had the opportunity to learn from other config managements and implement the good parts and just improve where possible. That said, I think Puppet has a very large barrier of entry. It takes a while to get anything done in Puppet, but once you get the hang of it, the syntax, the idea that it's not top to bottom, there are dependencies, it's modular. Once you get your head around that, it's a very powerful language and you get a lot of things done. But if you're just managing 1 or 2 servers, I think something like Ansible is way easier to get started in. But that's personal preference, I think.
Well, no, I think you're right there. It's taken me quite a while to kind of get that thinking across. And as you say, the building up, the idea of what Puppet is as opposed to Ansible, which has got probably better, like quicker time to getting stuff done that, it would work. Whereas opposed to Puppet is really, a way of thinking as opposed to anything else.
Yeah, and I think if you're looking at an infrastructure that is growing or that has just reached a couple of hundred servers, I think something like Puppet makes more sense because there's a lot of dependencies you can script. There's more interaction, more modular approach to everything. Whereas Ansible, I've not professionally worked with Ansible, just in my playtime. I think Ansible is very powerful, but starts to show its bottlenecks pretty soon. Whereas Puppet just it goes further. It's more scalable, to my opinion, but that's a tainted opinion because I'm using Puppet and not Ansible.
No, that's really interesting, and I mean, so I spoke a little bit about it, but I say your blog, and as I say, I really enjoy reading your blog and what you kind of get up to, and you have all these different experiments and kind of different good tutorials and things. And I'm just wondering, how long have you been doing? Long have you been blogging and kind of that as an outlet?
I started blogging the moment I started working. It started a bit of as a personal tool that I needed when I started working, which is now about 9 years ago, I think. We didn't really have a wiki or documentation, so I started documenting for myself, and I figured that this is a good way to get to know, the web, WordPress, anything that's blogging related. So I just started writing my own documentation on my blog, and that just sort of never stopped. So I've been blogging on and off for 7 or 8 years. I took a couple of sabbaticals, just some time off, because, if you're writing all the time, you either get a writer's block or it just doesn't interest you anymore. So
absolutely, yeah,
it's been a bit off and on.
But no, I mean, as I say, the content's all there still, and it's great content. And so from that, from reading your blog and stuff, there was one thing I noticed, as you say, you'd done a presentation on the topic for the show. Really, is this HTTP2, and I thought, it'd be great to kind of. I mean, we all know HTTP I think we all kind of have an idea about it, but really kind of go strip it bare, see what's like, what it really is, and then kind of build up work and build up building blocks of, each of the different parts, the history of it, the story behind it. And I know that you went through that in the presentation. I'll put that in the show notes. You did like a presentation for a local PHP user group.
Yeah, indeed. I've given it a couple of times now, as well as at a Drupal conference. It's an interesting topic to keep talking about, so I like giving that presentation as well. You mentioned that most of us, that are in the web development, know HTTP. From my experience, I've noticed that a lot of people think they know HTTP, but really getting the protocol, really understanding what's happening, that seems to be, for some tricky. And lately I've been enjoying teaching or educating everyone about what is this protocol, and if you upgrade to HTTP2, what are the advantages and what bottlenecks are you hitting, etc. It's a fun topic to keep talking about.
That's brilliant. Well, I mean, suppose for the first question is what actually is HTTP?
Well, it's a client-server protocol, so it's basically what has been powering the web. Without HTTP, we wouldn't be having not the internet that we have today. It's safe to say that 80 or 90% of all the traffic on the internet is probably related to HTTP, torrents beside. So it's the protocol that the web has been built on. It's what makes or breaks the new companies that arise. It's a simple protocol. In theory, you send a request to a server, you add some headers to describe what you want to see. Server does its magic and gives you a response back that also includes headers, just to describe what kind of response you're getting. And that's the gist of it. You send headers with a request, you get a response with headers that describe the kind of response you're getting.
And originally this was like introduced by Tim Berners-Lee. And I think like it was at 0.9 was released in 97 as a standard eventually, I think. Yeah. Somewhere
around mid-90s, the first drafts or the first standards indeed emerged. Not that much later, the first iterations of the standard emerged. The current version of HTTP, what we're seeing mostly is 1.1. But that's been around for on and off 20 years, I think. So we've been, that's a very long time.
That's it. Yeah. Cause I was saying thinking how frequently the updates are, and it doesn't seem that there are that many updates within, you just say like the last version is 1999 or something like that where we're using now, and not a lot of, the web's changed. Certainly the way that we use the internet's changed, but the fundamental protocol hasn't. So it's quite interesting to say then going to be able to kind of think what is going to be in HTTP2. And was there a lot of innovation throughout the time from when 1.1 was released to 2, or has it really been only the last couple of years that they've started thinking we now need to really think about this?
Well, we've had a lot of RFCs that detail the nitty-bitty details of HTTP 1.1. We've had RFCs that optimize the use of cookies or additional headers that servers can use, but really the protocol itself really hasn't changed. That had numerous reasons, but it mostly had as a result that we as developers or sysadmins started to get creative. So we've been working with a protocol that's 20 years old, but we're trying to do new things. We're trying to push this internet, this web to a new level, which is hard if you're working with tools that have been designed 20 years ago without a notion of the scale that the internet is running at.
They weren't thinking this was going to be the problem that they're meant to be solving. They were solving their problem at that time. They never could have envisioned what it's become.
Oh, and if you imagine what the internet must have been like 20 years ago, it's nothing like what it is today. The amount of traffic, the amount of requests per second that you're seeing, it's mind-boggling, but it's in no way comparable to what happened 20 years ago. So we've had this standard. It was a pretty decent standard, but it had its limitations. I've mentioned cookies already. Cookies is one of those hacks on a hack, which has lasted. It's done its thing for the last 20 years. It's still here in HTTP2, of course. But that was us being creative, thinking outside of the box of what we do and what limitations are we having that we can solve with something like additional headers. And that's exactly what we've been doing lately.
So really in the confines of what the protocol already describes. Yeah. Because that's another thing. People have HTTP and then you've got TCP. And I'm just wondering if you don't mind, like, kind of explaining the differences between that, because people do. I've known like people to kind of get confused by that and not work like what layers kind of they work at.
Well, we go back to the basics. If you're looking at that, we've got the OZ layer, which is, well, if you've done any kind of high school, middle school, college, no matter what, if you've looked at any of the programming or sysadmin courses, the OZ layer is there. It's a 7-step layer that describes from the cable that you're plugging into a server to the applications that are actually using it, and anything in between. If you're thinking of TCP or UDP or any of those low-level protocols, you're actually looking at layer 4 of the matter. It's a transport layer, which is just designed to get packets from A to B in a structural way. If you're looking at HTTP, you're looking at layer 7, which is several layers above. So when you're actually doing HTTP requests from, say, your browser to, say, Facebook, what happens in the background is a lot. You've got presentation layers, session layers, you've got TCP going on, you've got ARP addresses, MAC addresses, IPs, you've got physical layers going over switches and routers and firewalls. I keep saying this, but it's a miracle that the internet today works. There are so many things in between.
It is a crazy thing. And with that then, so you've got HTTP, you've got TCP, and and 1.1, as you say, it's been around for so long, and we really have kind of developed a lot of, in quote, best practices for 1.1 that, really kind of, again, hacks upon hacks, or, working within the confines. And one of the funniest of it, not the funniest, but one of the most interesting and really the most hacky is like something called like domain sharding. And I'm just wondering if you could maybe explain that and what that tries to solve within the problem of HTTP 1.1.
Yeah, sure. What domain sharding is basically you are spreading the HTTP requests that you have to make in order to get a website to work. So I'm looking at images, JavaScript, CSS files, even video files. If you browse a website, let's take facebook.com for example. If you browse it, your browser, your Firefox or your Chrome, will start at most 4 or 6 simultaneous connections to Facebook. That means if you're loading Facebook, it's notorious for images, CSS, JavaScript. You're probably doing in the background around 100 requests just to get the page to load.
Wow.
What your browser is doing is buffering them, or, well, not buffering them. It's using a concurrency of 4 to 8 connections. So it's launching a request for the first, say, 8 HTTP requests. It's waiting for them to come back, and then it's doing the next H requests, and then the next H. Which, if you're doing it all on one domain, is terribly slow. If you've got one very big image or a video or anything, it's blocking a connection that cannot be used for anything else. Domain sharding is one of those hacks that we developed just to get around that. It's where instead of just going to facebook.com, you're going to cdn1.facebook.com for your images, cdn2.facebook.com for your static contents like JavaScript, etc. And you're basically tricking your browser into thinking that it's connecting to multiple different web servers, so it would open up more concurrent connections.
Because there's that limit, isn't there, as you say, of how many TCP connections can be open per domain. And then you say, this is just working out. Okay, let's just say, no, pretend, let's just, the illusion that you've got more domains than, actually really do.
Indeed. And it came from the idea that there is a chance that these resources that you're requesting are actually hosted on different servers. Let's say they're actually on a content delivery network, that it would make sense to open more connections to that side. In many of the big websites, that is in fact the case. You're not just connecting to one web server, it's 10 or more in the background. But we have also been using this technique on smaller websites just to get a feel of snappiness and get a feel of faster response times when loading a website. So we've been abusing this system, for better or worse, by sharding, by adding subdomains that effectively refer to the same server and the same vhost even, just to get the content to load.
And then, and along with that is things like file concatenation and inlining. And it's so interesting because, part of a good best practice, development flow is, you're doing your development and then you package it up, you minify it, you concatenate all your files, your CSS, you concatenate your JavaScript, and hopefully you only have one JavaScript file, one CSS file, along with the actual HTML, page to go down the wire to the user. I'm just wondering, file concatenation, why is that such a big deal than having, let's just say, loads more, all these individual files?
Well, if you're a developer, you prefer your code, whether that's PHP code or Ruby code or your JavaScript code, to be modular, to have a logical separation. That means if you're writing JavaScript code, say, you probably don't want one big monolithic file, you want multiple files, just to have it easier to work with. Now, that's great for developers. It's easy for them to work with, more structure to their code, but it's not that fun for browsers, because if you need to request 20 JavaScript files, if we keep that concurrency in mind, they'll only be requested per 4, per 6, per 8. So that's why tools like, a lot of build tools have been developed to concatenate all of those files to keep your code modular into a big JavaScript file, so that your browser, what your client is requesting, only needs to make one HTTP request. The advantage is obvious that you just need one HTTP request. The disadvantage is that it may also be loading JavaScript files and content that may not even be needed on that particular page, that are just inside of the big monolithic JavaScript file. And they're just sent through the wire, just to have your browser only use one connection.
That is insane, though, that, you could think that actually downloading more content, just because of the fact that having that connection be created and negotiating all that, is actually more expensive. And I suppose this is things, again, like in this 20 years that we've kind of had to weigh up, where it's like, okay, do we have another file, or do we just concatenate it to that even if it's not getting used? And it's exactly. All these hacks, yeah.
It goes even further than that, actually. If we're looking at, say, the compression algorithms used to get data from server to client, you can achieve a bigger compression ratio if you have very big text files, because there's a chance that you can compress those text files even bigger, that if you have, say, 2 or 3 big ones, your compression ratio won't be as big. So there's the very difficult trade-off between how many concurrent connections do I want to start? Do I want to sacrifice another TCP connection for this? What is my compression ratio if I split them up or keep them in one file? There are so many things getting mixed up in there that for every application, it's almost a unique challenge to get the best performance out of it.
It's insane. And as you said, another one is inlining. Because that is even just within the payload of the HTML payload itself, that you're including all this other content, which can't be cached, really, but it's because of the fact that you then don't have to have this TCP connection created and used.
Exactly, and that's again the trade-off. It's about making a sacrifice between performance on the one hand and maintainability as a developer on the other hand. Inlining is great for performance in the sense that, well, you have the CSS straight away, your browser can render it straight away. It doesn't need to wait for either another CSS file or yet another include in that CSS file. It just has its markup, it can render it straight away, which is something that browsers like, but as you mentioned, it sort of sacrifices caching, because there is no CSS file to cache if you're inlining. You just
don't know, do you?
No.
And so with all these trade-offs, and they've been all these decisions throughout the 20 years, and now HTTP 2's come on the scene, and I'm just wondering, what does then HTTP 2 bring, along with its predecessors? Like, how has it grown in what it wants to try and solve?
It solves everything. Basically, we're out of a job. HTTP 2 is here, and every problem
it's
that
gone.
we
The
once had
internet's
is
done.
Yeah.
Finished. Project's over.
Yeah. So we can wrap off. Yeah. Been nice talking to you. Now, HTTP 2 is, for what it's worth, it's both a very big change and a very small step. I mean that by, well, let's look at HTTP 2. For starters, the currently most popular protocol is still the plain HTTP 1.1 that we're all using. It's been around for 20 years, and it's just the plain text protocol, because back then we only had plain text. HTTP 2 is no longer a plain text protocol. It's a binary protocol, which essentially means for us as developers, we probably won't notice that. But if you're into low-level debugging, what that effectively means is you cannot telnet to a server, write some HTTP commands, and expect a response, because the protocol requires something that is binary. You can't, well, unless you're some kind of guru, you can't really write binary code.
Yeah, unless you could be able to do that in your head, that would be pretty impressive.
Yeah, I think you're hired by Google. Even then. So that's one of the biggest changes. No longer plain text. Everything is.
So why is that then? Why was the decision made to go from a textual representation to binary?
Well, it's because of an ancient problem that they've been trying to solve, the concurrent connection issue in browsers. What that means is each connection that you're loading, each Each HTTP request, each JavaScript file, whatever, is another TCP connection that you're opening. You can't optimize that if the protocol remains plain text. What that means is, in HTTP2, everything's binary, but that also means that over one TCP connection, we can actually send and request multiple different resources. So that's what HTTP2 is bringing. It introduced a concept of what is called multiplexing. It opens one TCP connection to the web server. So your client only has one TCP connection to a web server, but over that stream, they can request multiple files. So they can request the homepage, some JavaScript files, some images, all over a single TCP connection. That means a lot less overhead on the TCP level, a lot less stress on the web servers for handling all those TCP connections, and a more efficient way of requesting and responding, but at the cost of no longer being a plain text protocol.
See, that's really interesting then, that, I mean, what's great about this is that, as you say, the domain sharding then, to me, it's almost like that can go away, that problem. I mean, you will still have, as you say, physical different locations on servers if you're very big companies and things, but this kind of, hack that we did where we would have the same, virtual host even, but it's just different domains on the outside, can kind of go away because of this multiplexing.
Exactly. In fact, if you're sharding at this moment and you were to upgrade to HTTP2, you'd be missing out some of the biggest benefits being a single connection, because each domain shard that you have, even if it's in the background pointing to the same IP address, still requires a different TCP connection because of another dependency on HTTP2 being it's all TLS encrypted. Every connection to a new domain that you open requires a new TLS negotiation, a new TCP connection, and well, you're missing out on the benefit of having a single TCP connection.
And as you say, so the domain sharding that you've actually done in the past as a quote best practice is now probably a anti-pattern because of the fact that it's going to be a performance hit because now of this having this single TCP connection.
Exactly.
And I mean, sorry.
Oh, go ahead.
I was saying with the binary protocol as well, I can assume, I've been reading up a little bit, and it feels that it's actually easier to parse is another reason why a pro for a binary protocol as opposed to just textual. They're easy, with like length encoding and things like that. They're able to quickly make parsers can be easily implemented as opposed to what it was in the textual representations.
Exactly. It's a lot easier to parse if you are a C programmer or anything low level. It's incredibly hard to parse if you're a human trying to read it. So just looking at the wire, let's say you're running a TCP dump on a Linux machine just to look at what packets are going back and forth. If you're looking at HTTP2, you probably can't make sense of it. Whereas if you're looking at HTTP1, which is comparable to a plain text protocol like FTP, you can just see in plain text what is going on. So it's easier for developers, for maintainers like libraries like curl or web servers. It's a lot easier to parse and effectively use HTTP2 correctly because, well, I said it before, HTTP 1.1 is built on hack, which means we've been getting creative on the headers we've been using, which makes it incredibly hard to parse in a correct way.
And I mean, with that then, so what are the tools that we can use? Are there many tools out now in the HTTP2 landscape that allows us to kind of get back what we've lost? In essence, we've been with this discoverability, like parsers that are able to parse it and then just display like things. I'm thinking like Wireshark kind of plugins or anything like that.
It's indeed funny you mentioned Wireshark because Wireshark has, since about a month or so, it has a plugin that can decode HTTP2 traffic.
Awesome.
Now, just to get you assured there, even because the protocol now is binary, it doesn't mean that our tools are suddenly useless. If we have a tool like curl, or if you're used to looking at the network inspector in your browser, it's not going to look any different because your tools, in this case either curl or the browser, will decode HTTP2 and just present it to you in the same plain text readable fashion that HTTP 1.1 has. So if you're looking at, say, your network inspector in the browser, you can see your request and your response headers. They'll look exactly the same in HTTP 1 versus HTTP 2. Just behind the scenes, everything's encrypted, everything's binary.
So that's the difference. So the difference really for a developer, a day-to-day developer, really is not that much in that regard because it's a binary. I know that's been very much a kind of pain point with people. People are either very much for or against this binary. What is your stance? Are you happy with that, or are you annoyed that you're not getting textual anymore?
I don't miss it. I have a lot of tools just to decrypt HTTP2 traffic. If I'm looking at, say, my Wireshark, or if I'm debugging something at curl, it doesn't really matter to me if I'm looking at a old spec HTTP1 or the new HTTP2, because my tools that I've been using for the last decade all still report to me the same output that I've been using for all along. So it doesn't make any difference. I think even if you're a PHP developer using the curl functions, you don't need to know that your endpoint that you're connecting to is either HTTP 1 or 2. Behind the scenes, curl will do whatever it takes to make that connection work. And you as a developer just see HTTP. It doesn't really matter which version you're looking at.
Well, that's great. That's a really good transition then. And you did mention the TLS connections and things like that. So a lot of, like the browsers now, they seem to just be supporting HTTP2 just through TLS. In fact, I haven't actually seen a browser support it, even though the spec says that you can support it without TLS. All of them seem to do TLS. Is there a reason behind that? Is it just to say, look, everyone should be on TLS now?
It's mostly that. We've been having a lot of privacy issues in the last years. We've had a lot of activists just promoting privacy and the security that it offers. When the HTTP2 RFC was once promoted and was in discussion, the first version of it explicitly mentioned that it should only work over TLS. So just to mention, TLS is the next version of SSL. It's a more safer, a more robust version of encryption. But that idea got shut down by a lot of agencies because they felt that forcing SSL or TLS was not the place, or the RFC of HTTP2 was not the place to do that. If we wanted to promote SSL, we should have done it in a different way. So the protocol of HTTP2 does not require TLS. Having said that, all the browsers, Firefox, Chrome, they'll only support HTTP2 over TLS. So the browsers have decided that TLS is in fact mandatory to run HTTP2.
And that's awesome. And, things like now the new, Let's Encrypt that's just been released out of, into public beta now is, it is relatively easy to get a TLS certificate. And,
exactly.
Be able to deal with this thing.
All the pieces of the puzzle seem to be coming together this year. At first, there was a lot of proponents over the TLS decision because if you look back 2 or 3 years ago, you had very cheap SSL certificates, but most of the organizations that needed one easily lost $100 per SSL certificate, which if you're forcing that upon a new standard, the new improved HTTP, sounded insane. Why would you force anyone to spend even more money on SSL certificates? So things like Let's Encrypt are awesome for this. They offer free SSL certificates, TLS certificates. So you can have, even if you don't have any money, you can have a fully valid HTTPS website. And it's even motivated other players, other commercial players, to also have a free offering in their catalog. So I think it's a very good move. And I think that in part, both HTTP2 requiring TLS and just Let's Encrypt offering it for free is just a perfect match.
Yeah, so you say it's all set, it's going on in the right direction, and it seems to, as you say, working really well at the right time, where people are starting to adopt this idea of HTTP2 and TLS out, and now Let's Encrypt now there. So no, it's really good because the cost. I think that's the thing where people would state, I've only got a blog. Why do I need to fork out money on a, to enable to be able to use TLS, be able to use HTTP2, fork out money for this. And if you can get free offerings like that, because I know there have been a couple in the past that I've noticed, but I mean, one of them had a very dodgy looking website. I can't remember the name, but, things like Let's Encrypt, having this kind of good backing and things like that, is a very nice thing to have.
Yeah, exactly. And I think in part, HTTP2 succeeding or failing is driven by services like Let's Encrypt, because it's not only, if you're a blogger, you're just doing it for fun and not exactly for profit. Why would you spend $30 or $40 a year for a stupid SSL certificate that you may even think it's not necessary? Why would you do that? If it's for free, you really don't have a choice. You have to do it.
Because another actually couple of things that I noticed, we're doing some reading on the topic, because was like with TLS, it was the fact that they found that a lot of software and hardware firewalls and antivirus software would actually block or remove HTTP2 traffic in plain text because it wouldn't assume, because obviously it's very different to HTTP 1.1, so it wasn't able to pass this correctly and be like, okay, this doesn't exist. So what they would do is just go through as TLS and be like, oh yeah, that's fine, because that's traffic they couldn't actually decrypt.
Exactly. If you're looking at traffic that normally flows over port 80 on a web server, it should be, in theory, plain text. It's what is expected from the now previous version of the HTTP protocol. So you've got a lot of intrusion detection systems, even firewalls, indeed, that if they don't think it's plain text, they'll block it because there's probably something wrong. I'm sure that has in part motivated the push to HTTPS. Yeah.
Because I mean, all these are wins. Having TLS is great, you know, and all these things that have to, you know, I'm always, because another thing I've realized and I've looked up was the fact that it's like the upgrade phase and the way that, you know, how do you go from, say, how do you promote that I can do a HTTP2 connection and actually upgrade to that?
Well, if you're a browser, you don't know beforehand that the server that you're connecting to supports HTTP2. So what happens is, for starters, you're just browsing at a website, usually on port 80. That website can say, I'm not only on HTTP2 or on HTTP, I'm also on the TLS version of this site, and it can redirect you to TLS. But then you're in a bit of a strut because you're connecting to a server on the same port that offers the plain text HTTP1 and HTTP2. So what browsers are doing is they're sending additional header requests to say, okay, if you support HTTP2, that would be great because I do. The server can then respond with, yes, I also understand this new protocol. Let's do some renegotiation. Let's get HTTP2 going. From that point on, your browser can, just like it does with 301 or 302 redirects, it can cache that this server has an HTTP2 protocol, and the next time that you visit it, it will prefer HTTP2. It will also fall back if it's, for some reason the browser or the web server no longer supports it. But the first connection that you're making to a server will always be HTTP1, just because it has no idea that the end site has
into it.
Yeah.
That's very cool. And talking about headers, actually, one thing that is very surprising from, you know, HTTP 1.1 was, you know, we've been able to gzip and compress our body content, but we've never been able to compress our headers. And headers have become larger and larger, say with the hack upon hack of cookies and things like that. Now it seems like in HTTP2 we get header compression using HPAC, and that's a really good win.
Exactly. Something that probably wasn't envisioned 20 years ago, that something as simple as headers could at sometimes exceed 500 kilobytes, even a megabyte worth of cookies. Because, well, right now everybody's just placing cookies and just another cookie. Oh, let's put one more. Oh, let's try to put a lot of data in a cookie. That sounds like a lot of fun. But every time that you, as a browser, are connecting to another page on the same site, you're sending all those cookies back and forth. And if that's not encrypted or, compressed, you're just wasting a lot of bandwidth because every request has all of your cookies back in them.
And I say this was not envisioned by the initial creation of this protocol, and that's what I say the hacks upon hacks that have added it. And now we're able to get around and say, okay, we really need header compression. And another one actually really interesting is server-side push. That gets a little more advanced. I'm just wondering what actually is server-side push.
Well, if we look back at the beginnings, if you're loading a website, you're loading, say, slash homepage, whatever, you're getting back the HTML. You're having to parse, you as in the browser, your browser has to parse all of the content. It has to find the references to JavaScript. It has to find references to CSS. If it's parsing CSS, it has to figure out that, there are other images that I need to download. So it's putting a lot of pressure on the browser to determine the best way to request additional resources. Because if you normally and do it as quickly as possible, indeed. Because if you're, say, requesting your images first, but it turns out that there's another CSS file that is overriding the properties of your previous CSS file, maybe you're doing work that isn't even needed because your image is no longer necessary. So it was a lot of pressure on the browser to be as smart as possible to make the next request. Should the next request be CSS or JavaScript, or what should I do to make it as fast as possible? Browsers have gotten really good at this, by the way, but it's not really the place of the browser to decide this. I think as a developer, you would be much more happy if you, as a developer, can say, what is the next request?
You know what you want to give them next. Like you know by what the product, the project you're working on, what is next needed.
You've built that website. You know that if someone is requesting the homepage, the next file should be this CSS file or this JavaScript file. If you as a developer could program that, that would be awesome, because you're saving the browser the work of having to decide which is the next resource. And that is what server-side push is actually all about. It is a way to, as a developer, determine the next request for your web browser, for your Chrome or your Firefox. But it doesn't offer it as, say, a suggestion. It just sends along the data straight away that you as a developer think that the browser might need. What does that mean? If you're loading a website, say the contact page of a particular website, you know that as a developer the CSS file is needed. You can add some additional headers to your PHP code or your Ruby code to instruct your web server, your Nginx or your Apache, to just send the CSS file straight away, even if your browser didn't request it yet. And this is a bit of the idea that your browser no longer has to parse the entire DOM. It doesn't have to find elements that it needs to fetch. It's already receiving the CSS file because your web server is pushing it into the browser itself.
That's really cool. That does give a lot of trust then to the server. I'm thinking there's, that allowing them to kind of do this is, can browsers typically just ignore stuff that, they bring down or not require it if they don't want this?
Well, a browser has two ways to control this. It can just say that it doesn't support server-side push, and then it just doesn't receive whatever it is that the server is sending. Or it can block an incoming request. So if you're sending a CSS file, but the browser already has it in cache because of a previous page, the browser can say, oh, hold off, I've got this file, let's get it over with. And that's possible. The browser, even though a lot of control is at the server, a browser can still manipulate or deny a request.
And along with that, then, is the request priority. Does that link into the server-side push, like saying say I want requesting certain assets before others and things like that?
Well, request priorities are in the other way. So it's the client that is connecting to a server. We've only got a single TCP connection. So the old days, you had your priorities by just sending, say, your CSS file and then your JavaScript file. You had an implicit way of ordering your resources. But if you're doing it all over a single TCP connection, you're basically firing all of your resources at the same time. And you don't know in which order you're getting them back. Priorities are used to have a bit of influence by the browser by saying, okay, I'm sending all of my requests at once, but my CSS and JavaScript needs a higher priority than my images. So you're getting them back in the order that the web server is still generating them, and it can choose to either honor the priorities that the browser has set, or just ignore them altogether and just send them every request that the browser made in one big file.
Cool. I mean, that's really interesting. That seems there's going to be a lot more kind of thought based on those kind of things, like what I should have the priorities at. Should I use server-side push and things like that now, as opposed to the whole domain sharding? So there'll be a lot more different best practices that will come along.
Oh, definitely. I think especially something like server-side push and the priorities, they are two systems working together. We've got browsers that have become very smart about which resource to load first, but we've also got developers that know their project and that know which file should have been downloaded first, and they can work together. So you can push the CSS file as a programmer, but you can still have the smart algorithms in a browser determine that a JavaScript file is or is not more important than an image.
Cool. So from there, we've got all these new features. For a developer, then now that they don't have to deal with the binary protocol, that they can still deal with them in their textual representation as we would expect it within Chrome and things like that. Well, is there any differences there syntactically? Any language changes? Any header type changes? Things like that?
Well, that's one of those things that critics say the HTTP protocol did not change enough. Everything that we know about HTTP1, all the methods, a post, a get, a put, even all the status codes for a 404, file not found, etc., everything remains the same. So if you memorized all of the status codes for the old protocol, they'll still work for the new one as well. And that is in part what critics, so they wish that the protocol changed more, because headers, in the way that we've been using them for 20 years, have their limitations, especially things like cookies. If you try to parse the cookie field, because it's pretty much a plain text field, anyone can put any content they want, it becomes very hard to parse. If that were as well an entirely binary or just a new format, the protocol could have done a lot more.
How do you feel about that? Do you feel there could have been more? Do you feel that's like incremental steps, large but small steps?
Well, if we look at the fact that it took nearly 20 years to get this version out, I'm glad that we just have a new version. And I also think that this version is a very good basis to rely all of the other changes on. The fact that we now have a binary protocol, that we have a single multiplexed connection, everything else that we do now, HTTP 3, 4, 5, whatever may come, is going to be a lot easier to implement, because this change was a really big one. It took 20 years to get just this version out. But I think right now we're ready for version 3, 4, 5, whatever, and that won't take that long anymore.
Well, that's interesting. Yeah, is the release schedule more set now that we've got this version? They're going to start pushing out more incremental changes because of how progressive this one's been.
I'm not sure. I haven't really been following any of the new specs yet, but it's this gut feeling. It's the feeling that everyone in the industry is happy that the HTTP2 is here now, that there is a foundation, a really good basis to rely everything else on. And I think that's going to push us to, I'm not saying we'll have a new version in 6 months, and I think 2 or 3 years we'll have a new major version that's going to be rather compatible with HTTP2, but maybe that's trying to solve other legacy issues that we're still having.
Like as you say, like the cookie one maybe, and things like that. And you mentioned that it is just a single TCP connection now. Is there any way of being able to tweak, will that be the default now, that you can get the same performance from using a single TCP connection with all these assets, or the browsers can intelligently open up more if they need be?
Well, the idea is that a browser doesn't have to open anymore, because opening a TCP connection is slow because of a simple method that TCP uses, and it's called a congestion window. Basically, whenever a TCP connection is made, it doesn't know that the remote site that it's connecting to can support small packets, big packets, or really big packets. So it starts off with very small packets just to be on the safe side. And every packet that it's sending back and forth, it tries to increase its window, its packet size. Which means that if you're the easiest way to see this is if you're downloading a big file. It can start off at 10 kilobytes per second and slowly ramp up to your maximum speed. That's your slow congestion window that you're still working on, which is being, excluded in HTTP2 because there's only one of those TCP connections. A browser would be foolish to open more connections, because in reality, it'll only be slower. It's much more efficient to keep using the existing TCP connection.
That's interesting, yeah, because you get that curve, don't you, where it's almost like the browsers and the client server are just trying to work out how fast they can actually work, and then eventually they fail, and then they're like, okay, we can stick there. And having that one TCP connection then means we can always just stay at that level, the optimum level for us.
That's exactly what it is, indeed. Yep.
That's awesome. And with this then, so you mentioned the tools that you've used. I'm thinking like servers and things like that, and things like Varnish and reverse proxies. And how is the adoption there?
Well, that's where it gets a bit tricky. We've had in our industry a lot of web servers that have pretty much been dominating us. We have Nginx, which is all around us. We have Apache, which is probably even bigger. And we have a lot of new web servers that are emerging because they saw the opportunity to implement HTTP2 before the big ones, before an Nginx or an Apache. So we have a lot of small web servers that act as a proxy, pretty much the same way that a Varnish or an Nginx could, just to offer HTTP2. NG HTTP2 is one of them. We've got Caddy, another popular web server, and they're all just being the extra layer on top of web server just to offer HTTP2, because Nginx now has built-in support for HTTP2. So if you're running Nginx and you're already running some kind of TLS certificate, pretty much enabling HTTP2 is just a one-liner that you have to change.
Oh,
it's
brilliant.
super easy. Apache, on the other hand, a bit more difficult. Apache, if you're running an older server, is probably on version 2.2. There's an experimental module that you have to compile yourself to activate. Exactly. Even if you're on a newer server, you may be running Apache 2.4, which means there's an official module, but most of the packages and distributions, so say you're running a Red Hat or a CentOS or any of the operating systems, there aren't built-in packages to run HTTP2 on Apache. Right now, the easiest way to run this is to run an Nginx server and have it do all the HTTP2.
Because I know that Speedy, you spoke about it at the beginning, was kind of a predecessor to HTTP2, and that had support in Nginx, am I right in thinking? Also Apache?
There were modules for Apache, but the same problem. You had to compile them yourself, and you had to keep them up to date. There wasn't a really easy to use package for Apache, and Nginx has always been at the forefront of this. But even Nginx, it took a long time for it to implement HTTP2. But I mean, it took several months, which in internet years is still a really fast time. But it gave a lot of others the opportunity to come up with a new web server, a web server optimized for the new web, for HTTP2. And I think Apache didn't really lose, or Nginx didn't lose a lot of ground because of it. But it was interesting to see how others took the opportunity to invent a new web server just for this protocol.
It's always cool when you get innovation like that with a new thing coming along, and it's not the same old, and new as you say, new people and new technologies can kind of come in. Because I know that Caddy, I was looking into Caddy, and it's written in Go and like these things, and it's really interesting, and it's nice that you can kind of look into these and have different technologies.
Exactly, it motivates all the others to keep moving at a faster pace and just to keep up with it. Because Nginx, even though it supports HTTP2, it doesn't support everything in the new protocol. There is no server-side push yet in Nginx, whereas NG HTTP2 does have it. And if you browse their website, which is a really cool trick if you're just wanting to get to know HTTP2, they serve their traffic by default on the new protocol, and they also use server-side push. So you can experience, if you open it in a network tab, you can experience what that server-side push is like. There is no delay between fetching the page and then all the assets. It's just the page and all of the CSS files straight away. But that is something that Nginx does not yet support. I have no idea when they would. They keep implementing new changes to HTTP2. They keep fixing bugs. So I think eventually it will come around, but when is the big question.
And one other technology that I'm a really big fan of, and I know that you are, is Varnish.
Yes.
Varnish cache. And I know there's been a lot of vocal kind of not liking HTTP2 from the main. I can't remember his name, but the main guy is not really
Paul Henning.
He's not a fan of HTTP2. Now, does that mean that it's not going to come in, or is it just going to take a little while?
It's probably just going to take a little while. Paul Henning is one of those proponents of HTTP2 because it did not fix all of the problems in the protocol. It's one of the biggest contesters in, well, we should have done more. But Varnish at the same time is a realist. It doesn't, it can't say that it will never support HTTP2 because that is where the industry is moving to. Right now, when you're running Varnish, even the very latest version, there is no built-in TLS. So if you want both Varnish and HTTP2, you're going to have to run some kind of proxy before it, either Caddy or Nginx or anything that has HTTP2 support. However, there is a plan, and I'm not sure which version. If I recall correctly, it'll be version 5 that is going to support HTTP2 in some kind of proxy method, so that if you want to run Varnish with the new protocol and you're running Varnish 5, which by the way is not yet released, I'm not even sure if it's actively in development, that will support HTTP2. But that is something that'll take a really long time. Because
I know that I know there's been work with the TLS stuff. That was another kind of barrier that people had, where it's like, oh, I want to use Varnish. Oh, I still need to have Nginx in front of it. And there's something called, is it Hitch? I think it was, that it's now like their own version of the TLS, and it just cuts it out. Yeah.
Hitch is indeed one of the TLS proxy made by the same people that built the Varnish tool, but it's a new tool. It's not built into Varnish yet. And indeed, it's one of those bottlenecks where you want the performance that Varnish can offer, but at the same time, you'd like TLS. Yeah. Right now, you have to use two tools, which means you have to manage them, which means that if something goes wrong, if a request fails, your debugging is going to be a lot harder. Because
that's it, extra logging, all kind of working through the story of how a request and response works.
Exactly. And that's where in-depth knowledge of the protocol comes in handy, because you need to know what your Nginx is talking to your Varnish and how your Varnish is talking to your Apache. If you can debug that, if you can see the flow of data, you can probably find out whatever it is that went wrong. But if that's not the knowledge you have, those kind of setups become really complicated and real time sinks where things just go wrong and you can't figure out why.
And with that, then, so like, how have you had a chance to implement HTTP2? Because I know that you spoke about it in your blog, that you've been able to do some fun stuff there. I'm just wondering, in your day job as well, has that been something that you've been working on?
Well, in my day job, it's a bit tricky. Nginx offers the new protocol, but they do so in what they call their mainline branch, which, despite what the name may sound like, it's actually their experimental, their beta
that
program.
does definitely not sound like a experimental branch, does it, main?
No, you would think that's their stable release, but no, that's what their new things come into, which means HTTP2, yes, it is running on Nginx, but it's not a stable release. So we've been offering it to a couple of clients that have agreed to the potential risk that is involved there. Not a single problem has occurred with them. In fact, they've been very happy. They see less TCP connections, meaning most of their websites just become faster, even without a single change to the website. Just enabling it meant that their data went through the wire faster, so everybody wins. But of course, the website isn't really optimized yet for HTTP2. On my personal projects, I've been enabling it wherever possible. Been playing a bit with Let's Encrypt just to get some free TLS certificates. And trying to benchmark what are the best practices, because it's, in theory, there are a lot of things you can do for HTTP2, but theory and practice, they don't always meet hand in hand. So it's really just benchmarking and just testing what works and what doesn't.
That's it, because we've got years of back knowledge and, history of the 1.1 protocol, 1.1 version, So yeah, it's kind of going through that again with 2 and working out where the best practices in quotes can be. And what's now anti-patterns. And I was just wondering, because the trouble is now, obviously, we've got 1.1 and now we'll have 2. It's kind of juggling, because actually a lot of what was good to do in 1.1 is now bad to do in 2 and vice versa. How have you been able to kind of think about how you would deal with kind of almost meeting in the middle, or maybe even having just 2 different experiences per, which can add quite a lot of, dev time and kind of thought?
Well, it doesn't only add dev time, it's really complex to optimize for both protocols. If you, say, are running a website that does show business or anything, you've probably got a lot of users that are still on Windows, on the Internet Explorer, whereas if you're running a tech blog like me, you're probably having a lot of users on Chrome and Firefox. Depending on your traffic, depending on the kind of people that visit your site, that should drive whether or not you can support a new protocol. I even saw a blog post by the Cloudflare team, which is a blog that everyone should read, I think, about even just dropping Speedy in favor of HTTP2. And they decided that's not even yet the time for it, because there are more browsers supporting Speedy than HTTP2. So even there's a really difficult trade-off that you have to make.
Because I know that Google have dropped Speedy support, haven't they?
Yeah, indeed.
Yeah, so even they've got... That's crazy. I mean, and I suppose, in your own opinion then, how long do you feel it's going to be? Is it going to be one of these things where it's like the whole PHP 5.3 thing, they're going to be using it for ages, and it will take ages for people to eventually adopt because of the fact that it's going to be a big switch?
I hope not, because 5.3 really is a big change for PHP. But I fear for some sites it will be the case. Now, the good thing is, because the new protocol is TLS only, there's a really simple question you have to ask first. If you don't have TLS, there's nothing to optimize. You can just keep using the old protocol. If you're on TLS or you have an interest in using TLS, there is no reason not to enable HTTP2, because even with domain sharding, even with inlining or concatenating everything into a really big file, HTTP2 offers enough benefits just to replace your HTTP1 stack. So even with no changes at all, enabling HTTP2 is 99% sure going to make your website faster.
That's brilliant.
But then it becomes more difficult, because if you start to optimize for the new protocol, you will be hurting everyone that is still accessing your site on the old protocol.
That is definitely, it's that trade-offs, isn't it? It is a massive trade-off again, where it's working out, and it's working out your own specific problem, your specific client use case, and benchmarking and seeing where you can get there. And so there's still lots more fun that people can have with the HTTP world. They can still do a lot of stuff. It's not just the silver bullet.
Oh yeah, I think if you're a beginning blogger and you need some topics to write about, HTTP2 benchmarks is such a big, massive hole to be filled. I think one of the biggest problems we'll be seeing with HTTP2 is web server support. So if you're still on an old server, there are chances that you just can't get the new protocol to work. And Internet Explorer.
It will always be IE. Yeah. There is IE.
Although they did now, or a couple of weeks ago, announce their deprecation of anything older than, I think, IE9. So there is work in progress, but I think...
Small wins.
Yeah.
Small wins.
I think the new protocol is only supported since Edge. I'm not sure if IE10 supports it.
That's scary, because that's only just been released, hasn't it?
Yeah, don't quote me on that. Maybe IE10. I'm not entirely sure, but it'll require a really recent version of IE before HTTP2 is supported. So if you get a lot of traffic from IE, you can still enable HTTP2. Again, it's more benefit than downsides, but I don't think you should be optimizing for HTTP2.
Well, thank you so much, Mattias, for coming on. It's been really interesting discussing this topic with you, kind of having, a really good exploration into this, because I do feel this is kind of the right time, similar to what you were saying, with Let's Encrypt coming in and things like that people will be spending a lot more and paying more attention to this topic, which really is what they should be, and they really should, because there are so many, different interesting things, in regard to it. I'm just wondering, is there anything else you'd like to kind of, maybe say, speak about, discuss, anything you want to kind of promote?
Well, I think we covered pretty much everything there is to cover in the new protocol. If you haven't heard of HTTP2, be sure to check it out, Google a bit. If I've got a lot of articles on my blog that say what's good, what's bad about it. Just make sure you're up to speed, because this is a new protocol. It's not going away. If you can enable it, just go for it. It requires TLS, so it requires your website to be encrypted, which is always a good thing to have. And if just anything else to plug, I'm blogging at a very difficult URL to pronounce.
But it's a great URL. I do love the URL. And also your email address. I won't mention that, but it's a great email address.
Basically, if you want to get in touch, have any questions, no matter what, you can find me on Twitter. I'm at Mattias Geniar. Something that you can't write at all. Just, I think, check
it will
the
all be in
notes.
the show notes for sure. Well,
okay.
Again, thank you so much, Mattias. It's been a great episode. And yeah, audience, we will speak to you next week. Goodbye.
Okay, thanks for having me. Take care.
You've been listening to 3 Devs and a Maybe. You can contact us at contact@3devsandamaybe.com or follow us on Twitter at 3 Devs and a Maybe.